Let me discuss about Fourier series. That is the case of odd and even functions under Fourier series. For that, let me take an example. Expand f of x is equal to x sin x as a Fourier series in an open interval minus pi comma pi. Before let me enter into the problem, we have to short look over the formulas that we are going to use in the given problem to find the Fourier series representation of the given function f of x is equal to x sin x. The first important formula you should know is integral u v dx is equal to u v1 minus u dash v2 plus u double dash v3 etc. Here both u and v are functions of x. Whenever you have the product of functions in terms of x inside the integration, you make use of this formula to find the value of the integral. Here u dash, u double dash and u triple dash etc. represents the successive derivatives of u. That means u dash is nothing but du by dx, where u double dash is nothing but d square u by dx square and u triple dash is nothing but d cube u by dx cube etc. Which means u dash means you have to differentiate u once with respect to x. U double dash means you have to differentiate u twice with respect to x, like that. So u dash, u double dash and u triple dash are successive derivatives of u, whereas v1, v2 and v3 are successive integrals of v. That means v1 is nothing but integral v dx. That is, you have to integrate v once with respect to x. v2 is nothing but integrating v1 once again with respect to x gives you v2. v3 is integrating v 3 times with respect to x. So already we have to integrate 2 times. That is v2. You have to once again integrate that with respect to x gives you v3 etc. So v1, v2, v3 etc. represents the successive integrals of v. And one more thing you have to remember is sin 2a is equal to 2 sin a cos a. This is a trigonometric formula you know already. And sin of minus theta is nothing but minus sin theta and cos of minus theta is nothing but cos theta. And next important formula you should know is basic formula of integration and differentiation that you know already. That is integral x bar n dx is equal to x bar n plus 1 divided by n plus 1. Whereas differentiating x bar n with respect to x gives you nx bar n minus 1. Whereas the second formula you should know is integral sin x dx is nothing but minus cos x, whereas integral cos x dx is sin x. Next, integral sin 2x dx is nothing but minus of cos 2x divided by 2. That is coefficient of x occupies the denominator. And integral cos 2x dx is nothing but sin 2x divided by 2. In general, we have tried integral sin nx dx is equal to minus of cos nx divided by n, whereas integral cos nx dx is equal to plus sin nx divided by n. And one more thing, this is the basic formulas of trigonometry. You know already, that is sin of a plus b is equal to sin a cos b plus cos a sin b, whereas sin of a minus b is equal to same formula, only the sin here plus change to minus, whereas cos of a plus b is equal to cos a cos b minus sin a sin b, whereas cos a minus b is equal to only here minus change it to plus. That's all. So from this we can write 2 sin a cos b. 2 sin a cos b is nothing but 2 sin a cos b. That means you have to add these two. Adding these two, so the second term automatically vanishes. So 2 sin a cos b is equal to sin of a plus b plus sin a minus b, whereas 2 cos a sin b is equal to, you have to subtract that. Okay, subtract these two. That is sin a plus b minus sin a minus b gives you 2 cos a sin b, whereas 2 cos a cos b is nothing but adding these two gives you 2 cos a cos b. That is equal to cos a plus b plus cos a minus b, whereas 2 sin a sin b is nothing but cos a minus b. Subtract this from this. That is cos a minus b minus cos a plus b. So remember these formulas, and then important formula you should know. That is the basic thing you should know is cosine 0 value is 1, whereas sin 0 is 0. Cos pi value is minus 1, whereas sin pi value is 0. Cos n pi is equal to minus 1 whole power n, whereas sin n pi is 0. And cos of n plus 1 pi is equal to minus of minus 1 whole power n. I will explain how this, because this is of the form cos a plus b. Right. That is, you have to take pi inside, means what happens? Cos n pi plus pi. That is cos a plus b. This is on the form cos a plus b. Cos a plus b is nothing but, already I told you what is the formula for cos a plus b. This is the formula for cos a plus b. Cos a cos b minus sin a sin b. Isn't it? So cos a, that is cos a cos b minus sin a sin b. So you know the values of all these. Cos n pi minus 1 whole power n, whereas cos pi is minus 1, sin n pi 0, sin pi 0. So which gives you minus of minus 1 whole power n. So no need to remember this formula. If you know basic formulas of cos a plus b and cos a minus b, what are that maybe? So you can just substitute the values and you can simplify and get this value. And like that, cos n minus 1 pi is also minus of minus 1 whole power n. because instead of plus here you have minus. But here for this formula you have plus here it's a plus, so you have the same value, right? And sin of n plus 1 pi is 0, whereas sin n minus 1 pi is also 0. And the next one you should remember is, while finding the coefficients an and bn, if the denominator consists of the term n square minus 1, what we have to means we have to go for the particular case and calculate the values of an and bn as a particular case. So if the denominator doesn't consist of n square minus 1, no need to calculate a1 and b1. Okay, let me now enter into the problem. Expand f of x is equal to x sin x as a Fourier series in an open interval minus pi less than x less than pi, right? So what we do as usual, you have to write down the given function. First given f of x is equal to x sin x, you have to write down the function along with the interval. That is very important. Okay, so as I told you already, so look at the interval minus pi. Here the interval is from minus pi to pi. As I told you already, the case of odd and even function arises only for the functions belongs to the interval of type minus pi comma pi, or it is of minus l comma l. So does it hold for the intervals of type 0 comma 2 pi or 0 comma 2l? That is the case of even and odd function. Does it hold for these two intervals of type 0 comma 2 pi and 0 comma 2l? So only case of odd and even function arises only for the two intervals of type minus pi to comma pi and minus l comma l. So look at the interval here. The interval is from minus pi to pi. So immediately you can verify whether the given function is of odd or even. Further, what we do as usual, you have to replace the given function x by minus x. If you replace x by minus x in this function, what happened? Minus x, that is x, replace x by minus x, and sin of replace x by minus x, that is equal to minus x sin of minus theta, as I told you already, minus sin theta, isn't it? That is minus sin x. That is nothing but minus and minus becomes plus, so you have x sin x. So that is your f of x, isn't it? So x sin x is nothing but your given function. So what we get? F of minus x equal to f of x. That is f of minus x is equal to f of x, which means what is the meaning? So the given function is, therefore the given function f of x is an even function. This is an even function. If it is an even function, you know the Fourier series representation of the given function. So let me show you the table. So leave this table, leave this. This is for 0 comma 2 pi. If it is under minus pi comma pi, we have three cases. Either it may be even or odd, or neither even nor odd. So now we are under this category. So the given function is of even type. So if it is of even type, we calculate only a not an. So the bn value immediately becomes 0, isn't it? So let the required Fourier series be f of x is equal to a naught divided by 2 plus sigma m is from 1 to infinity a n cos n x, where a naught is equal to, make use of the formula 2 by pi integral 0 to pi f of x dx, and a n is equal to 2 by pi integral 0 to pi f of x cos n x dx. Now let me first calculate the value of a naught. For calculating a naught, first write down the formula. So now let me replace, that is 2 by pi integral 0 to pi, where f of x is x sin x dx. So this is of the form integral u v dx, isn't it? As I told you already, integral u v dx, that is nothing but u v1 minus u dash v2. That's all. Because the next derivative of x becomes 0, isn't it? So we have to stop up to this. That is equal to 2 by pi u v1. You have to take this x as your u and sin x as v. U v1, that is x. v1 is nothing but you have to integrate sin x. Sin x integrating, you get minus cos x minus u dash. This is your u and this is your v1. U dash means you have to differentiate this u once again. If you differentiate x, you get 1. And v2. v2 is nothing but minus cos x is your v1. Integrating cos x, you get minus. Already you have minus, so cos x integrating, you get plus sin x. So already you have minus, so minus of sin x. That's all. So the next term doesn't, we don't have the next term, becomes here you have the first derivative of u 0. So we have to stop up to this. So the limit is from 0 to pi. So 2 by pi minus x cos x. Let me simplify and take the minus in here and make these two minuses plus sin x. The limit from 0 to pi. Okay. Now that is equal to 2 by pi Let me substitute the limits. First we substitute upper limit. So the bracket is must. So I just give you two parentheses, one for upper limit and the other for lower limit. First let me substitute x for pi. If you substitute x for pi, minus pi cos pi. You know the value of cos pi. The value of cos pi is minus 1. So minus 1 plus sin pi value. Sin pi 0 minus coming to the lower limit. So x cos x. So cosine 0 1. Whenever that is multiplied with 0, you have 0 here. Plus sin 0 is also 0. So there is no lower limit. Simplifying this, you get a0 is equal to 2 by pi. So within parentheses you have minus pi and minus 1. That becomes plus pi, isn't it? That's all. No other value we have. Only pi itself. So pi and pi being cancelled. The value of a0 you have calculated is 2. So now we calculate the value of a0. Then we calculate the value of an next. So to find an, we make use of this formula, that is equal to an is equal to 2 pi by integral 0 to pi f of x cos n x dx. That is equal to 2 pi by, just replace f of x by the given function, that is x sin x and cos n x dx. What I am going to do is, so I just interchange these two because in multiplication ab and ba both are equivalent, isn't it? For that I just rearrange the second and third terms, that is I have to write this as cos n x and sin x. This is for the simplification of my calculation. Okay, if you have continue like the if you have to continue this term without interchanging, that is also correct. Okay, to simplify my calculation and that will become easy for me, for that I have to interchange. Okay, so this is of the form. Look at here. So here x cos n x sin x. Here product of three functions are there. So we doesn't have any formula to evaluate this integral. So for that, what we are going to do is we have to make use of the trigonometric formulas that we know already, isn't it? So combine these two. This is of the form cos A sin B. You know the formula for 2 cos A sin B. What is the formula for 2 cos A sin B? That is equal to sin A plus B minus sin A minus B. But here we have only cos A sin B. So you take this 2 here to the other side, that is 2 by pi integral 0 to pi x. So this is of the form cos A sin B. So sin of A plus B. This is your A and this is your B. Okay, sin of nx plus x minus sin of nx minus x dx. Whole divided by, we have to take this 2 to the denominator because here we have only cos A sin B. We have the formula for 2 cos A sin B. So that you have to take this 2 to other side. So what happens? This 2 and 2 being cancelled. So you have only 1 by pi integral 0 to pi x sin of nx plus x minus sin nx minus x dx. So in your next term, what I am going to do is, I have to split this integral into two separate integrals. Okay, for that you have to take this x inside and also take this x, this is a common term. So you take it outside of sine functions. Okay, so that will be easy for us to integrate or differentiate the given sine function. Okay, so now your next step, that is equal to, that is here an, that is equal to, so let me take the first integral as 1 by pi integral 0 to pi x sin n plus 1x dx minus 1 by pi integral 0 to pi x sin n minus 1x dx. Look at here, this is a product, this is of form integral uv dx. So if you are very thorough about the basic Bernoulli formula, you have to continue like this. So to simplify this, what I am going to do is, I have to take the first integral as I1 minus the second integral as I2. Let me integrate these two separately and substitute here in an and get the value of an. This is what the procedure I am going to follow. Okay. So now let me first find the value of an. We first know the value of I1 and then calculate the value of I2. Now let me calculate first I1. This is my first integral I1. So that is equal to 1 by pi integral 0 to pi x sin n plus 1x dx. So let me apply the integration by parts. That is integral uv dx is equal to uv1 minus u dash v2. What is your u here? U is your x and v is sine of n plus 1x, isn't it? So, my make use of the formula, so that is u. v1 is nothing but integrating v, that is you have minus cos n plus 1x divided by n plus 1. u v1 minus u dash is nothing but this here u. So, differentiating x you have x1 itself and this is your v1. Again you have to integrate. What happens? Minus divided by 1 divided by n plus 1 is common. So integrating cos n plus 1 x you have sine of n plus 1 x and the denominator already you have n plus 1. So now you have one more n plus 1, that becomes n plus 1 whole square with the limit from 0 to pi. That's all. So let me simplify now. So you have to take minus to the front, minus x cos n plus 1x divided by n plus 1. Here these two minus becomes plus sine of n plus 1 x divided by n plus 1 whole square with the limit from 0 to pi. Now what we are going to do is, let me substitute the limits. So this is for upper limit minus lower limit. So the bracket is very important. That's why I am just first put the bracket for upper and lower limit. Okay. So first let me replace the value of x by pi. So minus pi cos n plus 1 pi. So I added, as I told you already, cos of n plus 1 pi value is minus of minus 1 whole power, isn't it? So I have write it here, minus 1 whole power minus to the front divided by n plus 1 plus sine of n plus 1 pi. You know the value of sine of n plus 1 pi, that is 0. Coming to the lower limit, minus 0. You just replace the value of 0, what we get? 0 into anything 0. First term becomes 0 plus sine 0 is also 0. So that's all. So what we are going to do is, we have to simplify this. 1 by pi, here these two minus becomes plus pi of minus 1 whole power divided by n plus 1. What happens? Pi and pi being cancelled. So you have only, so I1 is equal to minus 1 whole power divided by n plus 1. So we calculate the value of I1. So what is the value of I1 we calculated? Minus 1 whole power divided by n plus 1. So next we calculate the value of I2. This is the second integral is my I2, wasn't it? So for calculating I2, this is the second integral. So by making use of the formula, integral u b dx is equal to u v1 minus u dash v2. Here your u is x and v is sine of n minus 1x. So that is equal to 1 by pi. By making use of the formula, u v1, that is u is x, v1 sine of n minus 1x, you have to integrate what you get, cos of n minus 1x divided by n minus 1, u v1 minus u dash, differentiating x you get 1 and minus, while you integrating cos n minus 1x you get sin n minus 1x divided by n minus 1. Already you have n minus 1 in the denominator, so minus sin n minus 1x divided by n minus 1 whole square with the limit from 0 to pi. Let me simplify. So you take this minus to the front, that is 1 by pi minus x cos of n minus 1x divided by n minus 1 plus sine of n minus 1x divided by n minus 1 the whole square with the limit from 0 to pi. That is equal to 1 by pi. Let me substitute the upper limit first. Before that, bracket is must, as I told you already. First bracket is for upper limit minus the lower limit. So if you replace x by pi, that is minus pi cos of n minus 1 pi. As I told you already, cos of n minus 1 pi is equal to minus of minus 1 whole power n, isn't it? So minus of minus 1 whole power n divided by n minus 1 plus sine of n minus 1 pi. Sine of n minus 1 pi is 0. Coming to the lower limit, minus. Replace x by 0. If you replace first term x by 0 means this x is in product. So 0 into anything, 0. First term becomes 0. Plus coming to the second term, sine of 0. Sine 0 value is nothing but 0. So you have only 1 by pi. These two minus become plus. So you have pi of minus 1 whole power divided by n minus 1. What happened? Pi and pi being cancelled. So you get only I2 as minus 1 whole power divided by n minus 1. So this is the value of I2 we calculated just now. So let me substitute here. Minus 1 whole power divided by n minus 1, isn't it? So let me simplify this. What we are going to do? you have to take minus 1 whole power as a common term, take it outside. So you have 1 by n plus 1 minus 1 by n minus 1. Let me take an LCM. So if you take an LCM, what happened? Minus 1 whole power n denominator, you have n plus 1 product n minus 1. So cross multiplying this first term, you have minus n minus 1. Sorry, n minus 1 minus of n plus 1. You just cross multiply this. Okay. So in the numerator, you have n minus 1 minus of n plus 1. You take this minus inside. So what you get? Minus 1 whole power n minus 1 minus n minus 1. Whole divided by this sum from a plus b product a minus b, that is nothing but a square minus b square, that is n square minus 1, isn't it? So plus n and minus n being cancelled, so you have only minus 1 whole power n minus 2 divided by n square minus 1, isn't it? So the value of a n you have calculated is minus 2 times minus 1 whole power n divided by n square minus 1. So as I told earlier, after calculating the value of a n or b n, you have to immediately check whether the denominator consists of the term n square minus 1. If the denominator consists of the term n square minus 1 means you go for the particular case. That means this value of a n doesn't hold the value of n equal to 1. So what happens if you substitute n equal to 1? 1 minus 1, denominator becomes 0, a n value becomes infinity. That is the meaning why we go for the particular case and calculating the value of a n. So we calculate the value of a n and this goes for all values of n except at n equal to 1. So for that what we do? So let me first calculate the value of a n. So we calculate the value of a1. So for that we make use of the formula a n. In the a n you just replace n by 1. If you replace n by 1, what happens? a1 equal to 2 by pi 0 to pi f of x cos x dx. Isn't it? Just replace n by 1. You get a1, isn't it? So now that is equal to 2 by pi integral 0 to pi. Your f of x is x sin x cos x dx. So this is a product of 3 functions. So if it is a product of 3 functions, if it is product of 2 functions, we have the Bernoulli formula, that is integral u v dx. It is 3 functions. What we do? Combine these 2 functions and simplify this. This is of the form, you know already, the sine formula, sine 2a is equal to 2 sine a cos a. We make use of this formula. Here we have only sine a cos a. So we just replace this by sine 2a divided by 2 is nothing but sine a cos a. This is what we are going to do. That is 2 by pi integral 0 to pi x sine 2x divided by 2 dx, isn't it? So for make use of this formula, we have to replace this product of function as simple function like this. So these 2 and 2 being cancelled, so we have only, so a1 is equal to 1 by pi integral 0 to pi x sine 2x, isn't it? X sine 2x dx. This is of the form uv, integral uv dx. So if we make use of the formula uv1 minus u dash v2, isn't it? Integral uv dx is equal to uv1 minus u dash v2. So uv1, that is x. v1 is nothing but integrating sine 2x, you get minus cos 2x divided by 2 minus u dash is nothing but differentiating x, you get 1. v2 is nothing but minus of sine 2x divided by 4. Already you have 2. So here you have sine 2x divided by 2. That becomes sine 2x divided by 4. That's the limit from 0 to pi. Now let me simplify and then substitute the limit. So minus x cos 2x divided by 2 plus sine 2x divided by 4 with the limit from 0 to pi. So now let me first substitute the upper limit. So bracket is must as I told you already. So upper limit minus lower limit. So first replace x by pi minus pi cos 2 pi. You know the value of cos 2 pi. Cos pi is minus 1. Cos 2 pi is nothing but plus 1. So 1 divided by 2 plus sine 2 pi value 0 minus coming to the lower limit 0. If you replace x by 0, that's in product with cosine. So that becomes 0 plus sine 0 is 0. So you have only, that is 1 by pi minus pi divided by 2. That is pi and pi being cancelled. That is you get minus 1 by 2. So the value of a1 you have calculated is minus 1 by 2 alone. So you have to substitute all these values in the general Fourier series representation, but here you can't substitute this directly, so you have to expand this, that is a0 by 2, you have to take the first term outside of the summation. Since the denominator of a consists of the term n square minus 1, okay, so that's why you have to do this. So a1 cos x, if you substitute n is equal to 1 in the summation, you get a1 cos x plus, write down the remaining terms within the summation as it is. Sigma n is equal to 2 to infinity an cos nx. So you know the values of a0. The value of a0 we calculated is 2 divided by 2 plus a1 value we calculated as minus 1 by 2 cos x plus sigma n which is from 2 to infinity. The value of a you have calculated is minus 2 times minus 1 whole power n divided by n square minus 1 cos nx. So let me simplify this. 2 and 2 being cancelled. The first term 1 minus 1 by 2 cos x. Here minus 2 is a constant, so take it outside of the summation. Minus 2 times sigma n is from 2 to infinity minus 1 whole power n divided by n square minus 1 cos nx. So this is what the Fourier series representation of the given function f of x. So otherwise you can write this function as, you instead of taking minus 2 you can take plus 2 outside of the summation, 2 to infinity minus 1 whole power, you take add this minus to the power of n. That is also correct, okay, whatever that procedure you have followed. No. So the first and second term as usual cos x. So this is what the, or you can write like this, either you can take minus 2 outside or you can take only plus 2 outside and combine that minus with the minus 1 power. Both are the same, okay. So this is what the Fourier series representation of the given function f of x equal to x sin x defined in an interval minus pi comma pi. Hope you got a clear idea about how to find the Fourier series representation of the given function in an interval minus pi comma pi. Thanks for watching. See you all again in my next video.